Welcome, my honored guests, to a tech artist's guide to automated performance testing. My name is Matt Ostale. I am your tech artist and guide. And over the last couple of years, with the help of a lot of amazing people at Epic, we have been working to lower the barrier of entry to automated performance testing to make it a lot easier. It's been a wild journey, and I want to take you on that journey. So first, I kind of want to talk about why I think automated performance testing is so important, why I thought it was really important to lower the barrier to entry. I'm going to take you on the journey that I went on. I think there's some useful tidbits along the way, but it's not actually a guide. We're going to talk about that. And then we're going to talk about this new automated performance testing framework that we've got in 5.6. So I want to talk about automated performance testing as sort of a problem space first, because I have talked about this a lot, an awful lot about performance. If you were checking your performance early and often, testing your performance in consistent ways. Performance is everyone's responsibility. Testing early, often, and on device. But I love talking about performance, how you should be testing early and often.
To the surprise of nobody, I have more to say about performance, but that's a whole separate talk.
Welcome to the whole separate talk. So I'm assuming that because you were all here today, you were at one of my talks, you were at a talk about automated performance testing. I don't have to convince you of these things, right? I don't have to convince you to test early, because we've all been on projects where we didn't test performance early, and then a week before we ship, we realize that we're supposed to be running at 60 frames per second on the Xbox One, and we're nowhere close. We don't have to test our if we don't test our performance early, then we're going to miss everything, and we have to make dramatic cuts right at the end of the project, right? We've all been there. I see everybody nodding. I was on a project. I had to lower the dynamic shadow distance to 25% of what it had been originally, and I will tell you, I did not make any friends with the lighting team on that project. Right? And we have to test often. This can't be something that we're doing every month, every week, every 6 months, every milestone, right? Because we have to check often so that we're catching regressions as they arise. I was working on a project where we had daily performance tests, and one day one of our static cameras showed a 100% increase in frame time in an area that had been running perfectly fine for the entire project. So we went in and we checked, and it turned out that one of the VFX artists had checked in a 2048 distortion map on a full screen particle effect, and we caught it that day because we're testing often. And testing on device is really important, because I don't know about you, but that workstation over there that I develop on is very, very powerful and not representative of my players' experiences. And if we're testing on device, if we're testing on a consistent device, then we know that the results from today and the results for tomorrow are going to be comparable. The results that our teams are sharing with each other are all also going to be comparable. Because again, if I look at I've looked at projects on my, Epic provided workstation. I'm like, oh, that works fine on my machine, but that's not representative, right? And we have to be testing consistently, because even if we've got a camera frame that's right here and things are running great, but if there's a 5 million triangle non-nanite mesh right over here and we miss it, things are going to be, we're not going to be able to compare our results, because if I move the camera a little bit, the results are going to change. So we have to be able to test consistently. And this is a lot to deal with if we're doing it manually, which is why I advocate for testing automatically, because if you can do it automatically, then the rest comes with. So where are the tech artists in the room? And we're all kind of tech artists. I get it, right? We're the people that wear a lot of hats. And who in this room is responsible for their performance on their projects? I'm not, everybody's responsible for performance, but are you the person that people go to when things go wrong, right? Oh my God, we have to get this thing running, right? So who actually automates their performance? Who already has automated performance testing up and running? Hell yeah. One person. Great, but no, it's okay. You're in this room, right? You're taking your first steps. You're acknowledging that you want to do this, and I am here for you. And who likes automating things? Like, right? Like, clap for automation. I love automation. I don't like pressing buttons manually all the time, right? So we've got a lot of people in this room that are responsible for their performance. A lot of those same people are also tech artists, but we only have one person in the room who's actually automating their performance. And I have some theories as to why that might be. Because here's what kind of a rough outline of what you would need to automate in order to have like a one button press automated performance testing solution, right? We have to have something that makes the build, right? Step one, make the build. And then we need something to put that build on the device because of course we're testing on our dev kits. And then we need to tell the device to run the test and then get the results of the test from the device and then process those results into something that is readable by humans and then share those results with the rest of our team. And then ideally, we're doing this all on a build machine. And here's the thing, like a tech artist with enough time and space, because we don't ever have enough time or space to solve any of these problems, we might be able to find a way to automate all of this, right? And what do we turn to when we want to automate things? Anybody? Automation framework, good answer. I like to turn to Python. I love Python. I cut my teeth on Python. That's where I did a bunch of my early automation stuff. Here's the thing. Python is not what I would call the epic way. And in fact, we have a lot of systems to do things, to do all of these things the epic way. If I want to make a build, I use something called BuildGraph. It's an XML-based scripting system with graphs and nodes and building blocks so that you can construct kind of all of the things that you need to make a build of your Unreal project. And then for putting the build on the device, we have Gauntlet, which is part of the Unreal Automation Tool framework. That's written in C#. And then for running the test on the device, you're probably going to be doing something in C++, whether that is Gauntlet test controllers or like a simple automation test, those kinds of things. That's going to be C++. And then getting the results off the device, believe it or not, also Gauntlet. Processing the results, depending on what you're testing with, we have a couple of different command line tools to parse CSV Profiler or Unreal Insights. And sharing the results, that's kind of up to you. That's an open question. We'll talk about that in a little bit. And then finally, of course, on the build machine, we're going to be doing that with Horde, and we're going to be writing our job template in JSON. So tech artists, were C++ and C# part of your job descriptions? Like, did you have to know these things to get a job as a tech artist? No. One. Okay, I got one guy. So here's the thing. The tech artists are responsible for the performance of their projects. They like to automate things, but we don't necessarily have the skills to automate those processes, right? And that feels bad, and I get it, and I've been where you are, and so I want to take you on a journey, because this is kind of the hard epic way, right? This is not easy for anybody to set up. We're not SDETs, we're not build engineers. We might not even have people with those skill sets in our region, right? It's tough. So I want to take you back a couple of years. A couple of years ago, I told Jack that I wanted to do this talk because I had started to do some automation of performance testing on a project, and I was feeling pretty good about where it was. And I was like, I want to, present this to people and get them up to speed, get them on board. And as I started to build out the talk, it turned into, all right, so what you're going to do is you're going to copy this file from the Epic developer community, and then where it says replace project name, you're going to fill in your project name, and then you got to make a C# automation project file, and you got to do that, and you got to get it hooked up, and that, and then also you got to make your Gauntlet test nodes and make sure that you change the names of this here, and like that didn't feel like necessarily the right talk. That didn't feel like it was going to be terribly useful for people. So I want to take you on the journey. So that was about halfway through the journey. I want to take you on the journey of automated performance testing. Hopefully it will contextualize some of the stuff that we've been working on. So you know where we started, so you understand where we ended up. So first I want to start with like what a full manual process looks like. So the project I mentioned earlier with the 2K distortion map. This is an actual production process. Stop me if you've heard this one. So 8 o'clock in the morning, QA shows up. They download the latest known good build. They deploy that build to their device. And then for each map, for each camera in each map, type in a console command to go to that camera so that we have a consistent frame. And then we observe the average GPU times in something like pics. We record those in a spreadsheet, and then we email stakeholders with the spreadsheet, right? And then 10 o'clock, TechArt arrives because he had kind of a rough night. And he gets his coffee, and he reads his emails, and he looks for the red text in the spreadsheet, downloads latest known good build, deploys that build to his device, investigates the regressions to figure out what the heck went wrong that day, stops for lunch, and then resolves the regression either by negotiating with content creators or checking in the fix himself, right? Does this sound familiar to anybody? One? Okay, cool. So let's see how that stacks up. Did we make the build? No. I mean, maybe we had something that did a last known good build, but no, it's not part of the performance testing process. We had to put the build on the device ourselves. We had to run the test on the device ourselves. We had to get the results from the device. The results weren't even on the device. They were on our computer. Process those results. I don't know. Does conditional formatting count as processing results? No. Sharing the results, you still had to click send on that email. And of course, there was no build machine involved. So that's not great. That's not great. It's something, but it's not great. And it certainly doesn't scale. This was a production process on a project with 6 arenas. And a lot of people these days are doing something way bigger than that. We're doing 16 kilometer by 16 kilometer open worlds. And what used to be 10 static cameras might be hundreds across an entire open world project, right? So that's not great. So then fast forward to, I'm now at Epic. It's about 2020. I'm helping out the medieval game environment, the Quixel team. And I was like, hey, what if I helped you guys with performance on this project as kind of a test bed? And so I wrote a blueprint. I set up a blueprint because I didn't want to have to type in, bucket go for every single camera. So we get all cameras with tag, and then for each camera with tag, set view target with blend, resume tracing in Unreal Insights, and then pause tracing with Unreal Insights. And then I get these nice little sort of sections in Unreal Insights trace that I can highlight, and that lets me get the average inclusive time. I'm pretty proud of this process, if I'm being totally honest. And record that in a spreadsheet and share it. So let's go to the scoreboard for that. I still had to make the build myself. I still had to put it on the device myself. Get the results. I had to look at the insights trace, share the results. I'm still yelling at Victor and Jacob about that. And then of course, nothing's running on the build machine, but I'll give myself half credit for run the test on the device. All I had to do was a KE star start. Ooh. KE star, run perf on project. And that was kind of useful, but then as that project started to get used for more things, we were like, oh, let's test this console variable versus this console variable versus that console variable on different platforms with, is this nanite? Is this not nanite? And that started to not scale well, right? Because, maybe it was 10 cameras, but it's 10 different builds a day. And again, I am a tech artist. I don't like to do things manually. So let's start to get a little more advanced. Because what I do know is that if I launch a project with the command line argument with a path to some level, and then that question mark game equals, I can use the game mode alias to say, ooh, let's move all the blueprint logic I had into a game mode. And now I don't have to manually intervene in the project at all. I'm just running it from the target manager or something like that with those command line arguments. That launches it a lot faster. That's nice. And then in 5.3, we added these things called trace regions, which, oh my God, these things are so great. They're basically events that can span multiple frames. You set a start time and an end time with either trace begin region. There's console commands. There's C++ macros as well as blueprint nodes to do this. So if you wanted to do this as part of your blueprint, totally fine. And so then I could identify the cameras this way, which made things a lot easier to pick them out. And then we also have a command line interface for Unreal Insights. I'll walk you through this real quick. So there's a little bit of boilerplate. and then we tell it to open the trace file. And then this is the cool thing, this exec on analysis complete command. We say, when you have finished analyzing the utrace file, timinginsights.export timer statistics with a path to a folder and a wildcard character to a CSV file. That wildcard character corresponds to the region names. So if I name my regions for each of the cameras, now I get a CSV output of all of the GPU timer events for a specific region. So I can find the average inclusive time of the base pass, of unaccounted, and that will get dumped out into a spreadsheet, which for tech artists, we're now in CSV land. Like, I feel like tech artists can work with CSV files, right? I feel pretty good about that. So that felt pretty good. I still had to make the build and put the build on the device, but I'm going to give myself full marks for running the test on the device. And getting the results from the device, I still had to go grab the insights trace, but I could then run a Python script to parse those results. Sharing the results, still not great on this front, because I still had to, pull stuff out of the CSV, but it was a little better. And of course, we're still not running on the build machine. And at this point, I'm kind of pulling my hair out because there has got to be a better way, which in my mind is like the motto of the tech artist, right? There has got to be a better way to do this. And as I started researching and digging and pulling on all of these threads, I started to find BuildGraph. And don't worry about reading any of this text. If I wanted you to read it, I would have made it legible. So you find BuildGraph, and you're like, this is the thing that I use to make builds the epic way. And then you find build and test project, which is the thing within BuildGraph to set up, all right, I want to do these different target platforms and run these tests on the device. You find this target test list, and you're like, ooh, what's that? And then you start, Control-Shift-F, and you find gauntlet test nodes, which are things that are going to tell you, which tell the running session what to do. So now I don't have to launch on the device with a certain command line argument. I can actually, if you can see it there, I can say the client should launch with this map to that game mode, right? Now, okay, that's going to work a lot faster, a lot better. And then you find gauntlet test controllers because you realize that as this thing starts to get a little bigger, what if part of the thing that people want to test automatically is part of their game mode? And so if you override the game mode, then you're not testing the game mode, right? That doesn't make any sense. So you find these gauntlet test controllers. These are great because they can interact with the game mode. They persist between level loads, but they're not part of the game mode. Really, really useful. This is where you can do all of the logic that you used to do in Blueprint, but now this is all in C++, and that's a little scary for some people. And then what's really cool is as part of that gauntlet test node, when we launch the session, we don't have to do that map override. We say, hey, send in this controller and use that controller instead of everything else we were doing. And then you can run it as a command line from command line, run uat.bat, call the build graph, and then set a couple of different variables. And at this point, and then you go, now I can figure out how to run this on Horde. Finally, I can do this every night without having to run it by hand. This is amazing, right? So now I've got something that can make the build and put the build on the device and run the test on the device and get the results from the device and process those results, because you can actually, as part of the gauntlet test node, when everything runs, go grab your insights trace file and run the command line arguments on it and open up the CSV file that gets output and put those into a thing. And then maybe you can send it up to Tableau or Grafana or MongoDB Atlas, and it's all running on the build machine. And that sounds great. And it turns out that actually a bunch of our sample projects need testing too, right? City Sample has a sequence, but nobody knew about it. Titan just came out recently, and they needed some performance testing as well. And Lyra, of course, is a really good platform for it. And there's a lot of really common use cases, right? Most people just want to put a camera in the world and figure out how bad the GPU is at that point. Or they want to do a fly-through sequence and figure out how bad the GPU is at some point. Or maybe they've got a multiplayer game and they want to do a replay run. We'll talk about those in a second, right? So I'm starting to realize, all right, there's a lot of commonalities to what everybody wants to do with all of this. And I'm not an engineer, but if you have to copy and paste a bunch of code, you should probably be making a function, right? And if I have to tell people to fill in all of the boilerplate to do all of these things, I should probably make a plugin, right? And I need to define the epic way. Now you can start taking notes because, all up to that point, you were probably wondering, why is he not telling us how to do any of these things? It's like, well, this is a lot. And it was a lot to even just get through that section of the slides to get to the point where we can talk about the thing I want to talk about. So being the epic guy who cares a lot about performance, I started working on this framework. And because we've got BuildGraph and that's got command line arguments that then need to go into Gauntlet to get to the Gauntlet test controller, the framework is a contract between all of these different systems, so they're all working together in concert. Because any one thing, like if I tell you, oh, then set this command line argument, and then you don't set it up correctly to pass through, now there's additional problems. I wanted to make things easier. And we've got this plugin is now in, you can see it in 5.6, super cool. You see that thing right there? See that little purple thing? It's experimental. I really want to emphasize this. It is available. It is experimental because there are no guarantees. There are a lot of assumptions baked into some of the stuff that we've done already. The APIs are very much subject to change. The builds, you do need to be using source builds in a code project. Sorry. The extensibility, TBD, we're still trying to figure that out. Documentation, you're looking at them. The examples, though, we do have examples in Lyra Titan and City Sample. So when you pull those down from the launcher, I think City Sample isn't yet out for 5.6, but Lyra and Titan are. And there are examples of this framework in action over there. The version, it's definitely got to be 5.6, minimum 5.6. Because again, this is still very much experimental. But what comes in the box is everything that we just talked about. It's the build graph. It's the Gauntlet test nodes. It's the Gauntlet test controllers to do spawn a level sequence actor, open up a sequence. When the sequence starts, start CSV profiler, start Unreal Insights. Do it over a bunch of iterations, because now I can do like 6 iterations without ever having to intervene with the test, and I get better statistical significance out of that. It's all really fun, right? This is all covered. Here's where you come in. This is what I need you to do. There is a setup script because there's still like a little bit of boilerplate that we have to deal with. And it's going to set up the boilerplate that you need. You are, of course, going to have to set up your tests. I don't know what kind of sequence you want to, how you want to fly through your level. There is an XML file that you're probably going to have to modify at some point. I'm sorry. There are some command line arguments that you're probably going to have to set in a batch file that the setup script will provide for you. You're going to have to run the batch file. Sorry. And then look at an HTML file. We'll talk about that in a second. And then if you are signed up for Horde, if you're doing Horde stuff already, you can make the job template, and we'll talk about that in a second too. So let's talk about the setup script. This is it. This is the thing I need you to do. So remember all of the fill in the boilerplate that was going to happen 2 years ago? This is it. This is all you need. And again, don't worry. All of the stuff that is really important is going to be in the links that I'm going to share at the end of the show. So if you want to remember all this stuff, just wait. So yeah, we just run UAT. You just need to be at the root of your engine folder, add automated perf test to project, and then the path to your project. And what that's going to do is enable the plugin. You don't even have to do that yourself. And then it's going to create the 4 boilerplate files you need. You've got the build graph, the Gauntlet settings file, and then run local tests.bat and .sh. So this also works on Mac and Linux. And then it's going to add a sequence test to your project settings. I'm going to make an assumption that at the very least, we're probably just going to want to do a fly through. And I think for now, because again, this is still really new, we're going to start with a sequence, just a little fly through. We're going to put a camera in a world, and we're going to drag it through the world. So it's going to set that up for you too. And then there are a bunch of other test controllers, right? So we've got the static cameras, kind of like what we talked about earlier. So it's going to soak the frame at a specific point for a specified amount of time. This is great for just general GPU performance. Again, I've used that process on multiple productions, and it's worked out just fine. You just have to give yourself a little overhead. Like, if you want 30 frames per second, your environment should probably be about 25 milliseconds so that when gameplay happens, you've got some buffer. Sequence, tried and true. We play a sequence, and again, really good for environment GPU performance. And then depending on what you set up in your sequence, you can also test other stuff. Replay runs, we're going to talk about this in a second, but basically we play a match and then we can replay all the network traffic. And this one is where we can get into some really cool gameplay performance testing as well, because it's, again, playing back that network traffic. And then as a fun little added bonus, we've got this materials test type test controller, which just puts a material up as a full screen quad, which is good for evaluating the base pass cost of a material. So if you, like me, have evolved beyond the shader complexity view mode, the material test controller is really, really cool. And again, all of this stuff is set up in, this is all in project settings because I wanted to make this more accessible to more people, because the more time you tell people to like open a text editor to change a file, that kind of sets a level, a barrier to who's going to be able to do this. So, right, most of the configuration that you're going to need is going to be in these project settings. So let's walk through that real quick. So for sequencer, this one, I do have to explain this one a little bit. So in the project settings, there's this list of map sequence combos, because what I didn't want you to have to do is remember, oh, I need to copy the path string or the asset path or whatever and paste that into something. And what I also wanted you to be able to do is use the same sequence to test multiple maps, or test the same map with different sequences. I didn't want it to be like locked down. This map is this sequence. So you make this combination of a map and a sequence, and then you set its combo name, and that's how we're going to alias it when we're calling it via command line, or if we're going to set it up in our build graph. Talk about that in a second. Pro tip when you're setting up your sequences, because it doesn't rely on a level sequence actor being placed in the world, you should make the levels, the sequence that you're doing for your fly-throughs, everything should be spawnable. So like your camera rig rail, your camera crane, your camera should all be spawnable so that you don't have to rely on anything spawned in the world. And then when we set up, so don't worry, there's an explanation of this in the links in the EDC article, but there's this section in your build graph called like do if map sequence combo names equals nothing. And then this is just the list of map sequence combo names that you want to test by default when you run your build graph. And of course, right, there's static camera test is just a list of maps. And the way that we know what cameras you want to test is you have placed these automated perf test static camera actors in the level. There are still some open questions about how well this is going to work with world partition. So if you want to try it out and let me know how things go. And then similarly to the map sequence combo names, there's just you're going to add a section to your build graph that says, hey, these are the maps that I want to test by default. Replay runs are really, really cool. They are a whole separate talk, but the basic idea is they are recording network traffic and playing that back. So use it, really, really useful for automated testing. I will warn you, they can become stale during development, because if you're iterating on your level and you're like, I'm running forward, everything's fine. But then if level design comes in and says, no, actually, we want a wall right there, you run forward, you're running forward into a wall, and now your tests aren't comparable to each other. So then you got to go through and make another replay. There's also some issues like if you add replicated properties, things will break. So these are really cool. These are kind of the advanced version. But if you want to see how they're set up, check out Lyra. They are up and running in Lyra. And same thing. There's a little bit of build graph that you have to do. You know, the tech artist, I trust that maybe you can open an XML file and set up a couple of things. Again, boilerplate is going to be in the links at the end of the show. And then the material test, it's just a list of materials, super, super simple. You get a new CSV file for each material so you can process those things really easily. I love this. I need to start using this more as well. And that's all well and good. But how do I actually run the darn thing? So there is, as part of that setup script, like I said, we get this run local tests bat or shell script. I'm going to walk you through this. So it's first going to call run UAT with the build graph command, with the path to the build graph that the setup script set up and the target set appropriately. There's some boilerplate there, don't worry about it. And then the target platforms is, Win64, XXS, SSX, PS5, and so on and so forth. and target configurations. I'll talk about those in a second. And then we get into the stuff for the automated performance testing command line arguments. So with APT sequence tests, with APT static camera tests, and then the test types, which I'm going to talk about in a second as well: perf, LLMem, do insights trace, and do GPU perf. And then the number of iterations, because again, at this point, we're like, well, if we want to get 1, we can do like, I don't know, 6, and then we can kind of smooth out some of the statistical differences there in like, oh, I don't know, a butterfly flapped its wings and now my GPU is running a little hot, and so the timings are a little off. And then generate local reports equals true. We're going to process the CSV files that come out of these tests and give you an HTML file that is a spreadsheet that you can share with your friends. So target platforms, right? If we're testing on PC, the one thing to watch out for is that the test is going to run on the computer where you double-click the batch file. So if you are like, oh, I want to test this on my min spec or my recommended spec, you actually have to physically go to that machine and press the button, because we can't say from that machine. We can't treat Windows machines like a dev kit, basically, is what it comes down to. But for consoles, right, you're connected locally or remotely. Gauntlet is going to figure out like, oh, if I'm connected to this dev kit, I can just, and I'm supposed to be running on this dev kit, I'm going to go put the build on the dev kit, run the device, and pull everything back. And for mobile, again, as long as you're connected, you should be good to go here. But right, all of that stuff is going to go into that target platforms list. So if you're like, oh, by default, I want to test on Windows and Android, you're going to update your batch file to do that. And then test configurations. This thing, usually as a tech artist, I don't expect you to have to interact with this all this much, because usually we're doing development, right? We're going to get a lot of information with some additional overhead. Or we're going to do the test configuration, which gives us slightly less information in exchange for less overhead. It's going to be closer to the shipping experience. There's the debug configuration. This is not for us. This is not for our purposes. Don't worry about that. And then the shipping configuration, you get hardly any information because there's no overhead. But it's not really for this purpose, because we do need more of the information for giving us more of the numbers, right? But shipping is like the thing that you send out to your customers. And then there are the test types that we talked about earlier, right? So there are 4 of them that we need to care about today. There is the perf test type, and this is going to run with a free dynamic resolution. So if you've got a supported platform, we're going to use that dynamic resolution because it's going to be more representative of the player experience. And the key metrics here are not going to be necessarily frames per second or average GPU milliseconds because of that dynamic resolution. So instead, we're going to use a couple of different metric types, which I'll talk about in the next slide. And then the other test type that I think is really useful is LLMem. And this is going to be specifically looking at memory. We say, hey, I want more memory statistics out of the game, which is going to cost you some performance. So we kind of have to split those two things out. There's also the insights test type. What I like using this for is I'll do like 1 run of those and 6 runs of perf. And then if something goes wrong in the perf test, I will look at the insights trace because I really like using Unreal Insights. And then finally, there's the GPU perf test type, which will run at a fixed dynamic resolution. And so if you really want to look at GPU milliseconds, this is the test type that is going to work for you. So let's talk about those metrics for a second, because there's some really cool stuff in here, right? So MVP stands for missed vsync percent, which is computed by the perf report tool based on your target FPS and the actual frame time that was observed on the thing. And it's telling you what percentage of time out of this test did we miss our target frame rate. So if it was 50% of the time, you know that 50% of your frames were above 16 milliseconds. That's not great. We want to aim for a lower number there. And then that dynamic resolution percentage, again, on the supported platforms, but this gives you a representative idea of shipping. And this is kind of a stand-in for the cost of a frame, right? If I'm running at 45% dynamic resolution at 16 milliseconds on the GPU, that's not necessarily what we might want in most situations. We'd want that to be more like 55, 60, 75. And then hitches per minute does what it says on the tin, but it's going to show you the outliers. So if you've got every minute, you've got one frame that takes 60 milliseconds instead of 16 milliseconds, this is where you're going to see that instead of looking at like average frame time. And then, of course, there are timer averages, right? Milliseconds for game thread, for GPU, all that other fun stuff. This is going to help you show that. Those roughly align with everything that you see in stat unit. Don't worry about those too much. And then at the end, this generate local reports option is going to give you a summary table.html, which is going to be saved in your project directory based on the test type and a couple other things. And this is going to show you the results of your tests. So like in the test that I was working on, we have the map sequence combo name. So I know that it's the perf sequence that I'm working with. The target FPS, this is not the actual FPS, because as you can see, in 2 of these tests, I had a 50% missed vsync percent. Half of my frames took longer than 16 milliseconds, which is not great. I had a bunch of hitches. My frame time average was about 30, and I can tell from looking at this that my RHI thread was probably where things were causing problems. Again, this is kind of the thing that you can share with your team, right? I can just take this HTML file and send it out. This report link here, that goes out to a sort of a per thread breakdown. We can take a look at those later. Personally, I prefer Insights for that purpose. So let's look at the scorecard of this whole process, right? I'm going to give myself some gold stars. We're going to make the build. We're going to put the build on the device. We're going to run the test on the device, get the results from the device, and we're going to process those results. Sharing the results, still an open question. We'll talk about that. And running on the build machine, it doesn't make the job template for you because of some things that we can talk about later. But that's where you come in, actually. I need you. I need your feedback. I need more people to use this. I have precisely one person up to this point has confirmed to me that this thing works in the outside world. I know that at least one person has gotten it to work under the very restrictive conditions of it's a source build, it's a code project. That code project resides at the root of the source build parallel to the engine folder. And I coached them through it and I had a whole script for them. So I want your feedback. Like, how do you want to test your performance? Does static camera sequence and replay runs, does that cover it for most people? How do you want to be able to share the results? Are there things that we could be doing better on the configuration side of things? I want to know. So yeah. All right, that's my time, everybody. Thanks for coming out, hanging out.